Hi everyone, welcome to section 2.3, solving multi-step equations. So in the section 2.2 we solved one-step equation. You just had to add or just subtract or just divide or just multiply. Now we've got multi-step. We're also going to talk about some consecutive integers. You might see this up here. Consecutive integers is all about setting up an equation. So first of all, a multi-step equation is an equation to solve with more than one step to isolate that variable or solve for the variable. For example, we might have a 2x minus 7 equals 13. We're not just going to add 7 or just going to divide by 2. We're going to do both of those things in a very specific order. So just like the last section, we're still using inverse operations. However, when you're solving the equation, you actually use PEMDAS backwards. We follow the order of operations or PEMDAS backwards. So the first thing you're going to do is typically get rid of adding and subtracting first, multiplying and dividing second. Of course, in math, there's always exceptions to every rule, so we'll do an example or two that is different than that. And of course, just like our last section, we're going to work until the variable is isolated or our coefficient is 1. In the example I wrote up above, the coefficient was 2, so we know we'd have to divide by 2. That would be last, so we'd start by adding 7 to both sides. Dividing by 2, we'd get a nice, neat answer. So let's do a problem like number 2. We'll do actually a couple of them because I want you to see. I feel pretty okay about a problem like number 1. Go ahead and do it if you want to. And I need to talk about those directions where it says check your solution. So for problem number 2, the first thing we're going to need to do, we've got an over 8 to get to our t, and we've got a plus 21. Here's our variable. So we're going to get rid of adding or subtracting first. So that means we're going to have to subtract 21 from both sides. When I subtract 21, please show your work so that I can see that you've got a t over 8 equals that negative 7. Check my math too. Once you do that, we know to get that 8 or that t by itself, we're going to times both sides by 8. So when I do that, those guys cancel out and I'm left with a t equals negative 56. I just want to mention the check step. If we're going to check, you would take that negative 56 and use substitution and put it back in there. And you could just do a little mental math. And basically, it's a true or false like those replacement set problems. Negative 56 divided by 8 is negative 7. Negative 7 plus the 21 from the problem does give you a 14. So we know we've got ourselves a correct answer. Let's jump down to number 4. And then I want to go over to the side to number 3. Because I notice in numbers 3 and 4, I've got fractions in both of them. And we're going to kind of walk our way through this. So in number 4, I've got a 2/3 times x plus 5. And that's got to be equal to negative 7. So I'm trying to figure out what value of x will make that statement come out to negative 7. So just like the last problem, we're going to start by getting rid of adding or subtracting first. Because I've got a 2/3 times x and a plus 5. So I'll get rid of that minus 5. Please notice how I'm showing my work. Some of you like to write your work across. It makes it very confusing. Go up and down. Start from now. And that should be a negative 12 if I did my work right. And now it's 2/3 times x. Recall back from section 2.2. I don't divide by 2/3 even though it's timesing by 2/3 because I'm going to multiply by the multiplicative inverse, also known as the reciprocal. That way you don't have to worry about the order you type into your calculator or anything else, because if I did the math over on this left-hand side, it would be a 6 over 6x, which becomes a 1x. On the other side, feel free to go to your calculator, mental math, whatever tricks you've got. That should come out to an 18 negative, because it's negative 12 times positive 3/2. If you divide by 2/3, you type in negative 12 divided by 2/3, and you'd still get a negative 18. So let's jump over here to problem number 3, because number 3 is also a fraction, right? P minus 15 all over 3 equals negative 6. Here's the problem. I cannot get to that minus 15 to add 15 to both sides. until I get rid of the fraction. Since the variable is up in the numerator with a whole bunch of business, I've got to get rid of the fraction or the dividing before I do anything. So please make yourself a little note how 3 and 4 are different, because in number 3, I'm going to multiply first, because when I multiply, those 3's cancel out, and I'm left with the p minus 15. Negative 6 times 3 is negative 18. Now I can do my very simple add 15 to both sides, so I isolate that p, and I end up with a p equals negative 3. Again, I could go back up to my original problem. I could put a negative 3 in here. Negative 3 minus 15 is negative 18. Divide that by 3 and I get a negative 6. I get a true statement. So feel free to, there's a built-in double check that you can use if you want. So please note the difference between 3 and 4. And then we go to these word problems. I think we're going to be okay with these. I don't know if we need to do a bunch of examples, because section 2.1 was all about writing the equation. Now we're just going to solve them once we've written them. So I'm going to skip over those two because I do want to talk about consecutive integers. Consecutive integers, everybody knows what integers are, right? Whole numbers, positive and negative. It does include 0. So when we're talking about consecutive integers, we're talking about the integers in order. No skipping around, not like 1, 9, 15, negative 2, 7. Instead, I would say like 1, 2, 3, 4, 5. Or 2, 3, 4, 5, 6. No skipping. No going backwards, no nothing. So consecutive even integers, we're going to say even integers that are in counting order. So what's my first even integer? 2, 4, 6, 8, right? And on and on and on. How do you get from one even number to the next even number? You pattern people. How do I get from 2 to 4? 4 to 6, 6 to 8. So I add 2 every time. How do I get from just a plain old consecutive integer to the next one? My list up here, 2, 3, 4, 5, 6. What's my pattern on this one? Add 1, add 1, add 1. Right? So anytime I want to get to the next whole number, I just add 1 to it. Anytime I want to get to the next even integer, I just add 2 to it. Well, guess what consecutive odd integers are then? Odd integers that are in counting order, no skips. So what's my first odd number? 3, 5, 7, 9. The list goes on. Here's the question I'm going to ask you that sometimes messes people up. You got to think long and hard about that. I just asked you about the pattern for plain old integers. We add 1. The pattern for consecutive even integers, we add 2. What's the pattern for consecutive odd integers? How do I get from 1 to 3? 3 to 5, 5 to 7. Some people don't like it to be an add 2 because you're like, but they're odd numbers. But we're still skipping over 1 every time, so we're going to add 2 every time. So we could have a problem. Actually, let's skip to the next page. Keep that in mind. And let's kind of talk through this, setting up an equation for these problems. So we'll do 6a. It says to write an equation for each problem, then solve it and answer it. So it says to find 3 consecutive integers whose sum is 57. Well, first of all, here's my is, right? So I know that it has to be equal to 57. And then this word, sum, what does it tell me I'm going to do with these 3 numbers? I'm going to add them all up. So something plus something plus something, because it says there's 3 of them. All right, so here's where you got to start thinking. Consecutive integers. Look above to see what was the pattern for consecutive integers. We add 1 every time. So if this number, first number is what? Something we don't know. Say it's 7, which it's not, but just pretend. What does the next number have to be? It has to be that number plus another 1, right? So if this guy right here was 7, then this one would have to be 8, and this one would have to be 9, so I'm going to make that plus 2. If I had another number after it, I'd do x plus 3. If I had another number, I'd do x plus 4. So every number, when I ask for consecutive integers, I add one more. So now I've got like terms. I've got an x plus an x plus an x. That's a 3x plus, I've got 1 plus 2, and that's still got to be equal to 57. And now I've got myself a two-step equation. Let me try that again. No, maybe not. Here we go. Now I've got myself a two-step equation, so what should I do first in order to solve that? Take care of adding and subtracting first, so I'm going to subtract 3, so 3x must be equal to 54. And now let's go ahead and divide by 3. So my first number has to be, what is that, 118? So if this number is 18, what does this number have to be then if it's the next consecutive integer? Or 18 plus 1, that has to be 19. What does that third number have to be? So 18, 19, and 20. It does say to find the 3 integers, so that's why I wrote those all down and put a box around them. We'll talk more about those, but kind of get used to that. Double check what that setup looks like. Get used to those problems. And then last but not least, I've got a word problem. I want you to kind of think through it. Some people can just common sense their way through this. So the question is asking, what is the amount of her allowance? Go back and look through and see. So lesson summary for today. How would you explain consecutive integers in your own words? So that the notes part and the problem we just did, how would you explain consecutive integers to somebody who didn't know what you were talking about? And please go ahead and solve this problem. That looks a lot like example number 3. Please tell me what x is equal to. Have a great day. We'll see you next time for 2-4A.